Hi guys, welcome to Vector Trees. Vector Tree will be talking everything with relation to planes. So we can touch on point to planes, line to planes, and relationship between planes as well. Okay, so first off, we're going to learn how to actually find vector equation of a plane, followed by scalar product of a plane and Cartesian equation of the plane. So the first one we'll be talking about is vector equation of plane. So if you can recall very quickly, in vector 2, we did learn that vector equation of a plane is L, R equal to A plus lambda D, where lambda is a real number. Now, R stands for any point that lies on the line, A stands for a point that lies on the line, and D stands for a direction that the line is parallel to. So for vector equation of a plane, generally is very similar to the line. So if you can quickly draw out, now this is my plane equation. I will need a point, I will need two directions, okay, and these two directions must not be a direction that's parallel to the plane. What I mean is that the two directions must not be parallel to each other, and they must be parallel to the plane. Okay, so a line for a plane equation, R, okay, R stands for any point that lies on the line, equal to A, which represent a point that lies on the plane, plus lambda direction 1, plus mu direction 2, where lambda and mu are real number. So to form a vector equation of a plane, I will need a point, and I will need two directions that are not parallel to each other. So from here, we're going to run on to touch on these two examples over here. First example, planes contain point A 102, point B 248, and point C 3, minus 2 and 2. Recall, I'll need two directions, I'll need a point that lies on the plane. So over here, since I have 3 points, if you can quickly draw out, it's going to look something like that. Okay, where point A, B, and C are going to lie on the plane. So for me to form two directions, I can either use AB, AC, or BC, or CA, doesn't matter, so long it's two directions that's parallel to the plane. Okay, and I can use any point. I can use point A, I can use point B, or point C to form the vector equation of a plane. So what I'm going to do here is I'm going to find AB first. So AB is equal to OB minus OA, so it's 248 minus 102, which will give me 1, 4, and 6. Next, I'm going to find BC. Like I said, you can use AC, you can use CB, whichever direction you want to. Okay, BC is equal to OC minus OB, so it's 3 minus 2 and 2 minus OB, which is 2, 4, and 8, which will give me 1 minus 6 and 6. Okay, take note, because we are talking about direction, we can simplify direction if you can. Okay, however, over here, this will be the most simplified direction that we can get. So to form the vector equation of a plane, it will be plane pi, which can be represented as plane, R equal to A, so I can use point A, point B, or point C, doesn't matter. So 102, which I use point A, plus lambda, 1, 4, and 6, the first direction, plus mu, 1 minus 6 and 6, the second direction, where lambda and mu are real number. Okay, take note, please do remember to write lambda and mu as real number, because without writing that, you will definitely be deducted mark in your exam. Okay, we're going to talk about point 2. Okay, part 2 consists of the plane will consist of a point A and a line direction. Okay, so you do realize that the line already given you one direction for your plane. However, you will need another direction over here. And from the line equation, I can see that 1, 2, 1 is a point that lies on the line. So this can be 1, 2, and 1. So since I have 2 points here, I can essentially find a direction to give me the second direction of the plane. So the plane equation, first I need to go and find the direction first. So I'm going to take 1, 2, 1, minus away a point A, which is 1, 0, 2, which will give me 0, 2, and minus 1. So this will be a second direction. Okay, so a plane equation will be R is equal to 1, 0, 2 plus lambda 0, 2, minus 1 plus mu 1, 1, 1, which is derived from a line equation, where lambda and mu are real number. So take note, this is how we actually form the vector equation of a plane.